Here we go. The following Zoom session will be is being recorded and will appear later today on my YouTube channel, Math with Mayo. When you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Today we're going to go on and look at section 8.9 and wrap up this chapter. Your homework over the weekend will be 8.9 as well as the chapter review. Monday we'll review, and then Tuesday there won't be any class meeting. You will just take your chapter 8 test. Okay, having said all of that, are there any questions from section, what was it, 8.5, I believe, from yesterday?
No, I don't have any.
Okay, how about
No,
you?
I didn't have any questions.
No questions? Okay, then we'll just go right on to section 8.9, which the topic is variation. And there are 3 kinds of variation we're going to look at. The first one is called direct variation. And a general formula for that is y equals k times x. Now, we're going to look at 3 different types of variation: direct, inverse, and joint variation. All 3 of them have k in their formula. K is called the variation constant. It's also called the constant of variation. It's also called the constant of proportionality, just different names for the same thing. I go with this name because it's the shortest. So that letter actually represents a constant, not a variable. But often what we'll have to do in the problem is determine what that constant is, okay? So as an example, would one of you like to come over to my house this weekend and rake leaves? I'll pay you well, just, you know, super lots of money. Either of you interested in that? Maybe?
I will, for $1 million.
Right. Okay, what's that? $1 million? Well, not quite that generous, but here's the deal, okay? If you come over and you work for me 5 hours, I will pay you $100, okay? So X is going to be the number of hours that you work, and Y is going to be the pay, all right? Now, based on that, what is your rate of pay? Well, let's see.
$25 an hour. Oh, sorry. Are you going to write an equation?
No, go ahead. Now that's not K of 5, that's K times 5. Okay, careful. Would it be $25 an hour?
20, sorry.
There you go.
Mm-hmm.
Right. So basically, from that starting information, you could determine that K was 20, right? So now, based on that, what if you came and you worked 6 hours? How much would you get paid?
$16.66 or 67.
No. Okay, we know that K is 20. So now our equation is this. So if X is 6, what's Y? What's 20 times 6?
120.
There you go. What if you worked 7 hours? What would you get paid? Wouldn't it be 7 times 20?
Yeah, 140.
Okay. What if you worked 3 hours? What would you get paid?
60.
And how about 2 hours?
40.
All right. Now, what I want you to see is that as the number of hours that you work goes up, your pay goes up. As the number of hours you work goes down, your pay goes down. So hours worked and pay move directly. One goes up, the other goes up. One goes down, the other goes down. So they move directly. Okay, so that's direct variation. This also looks a lot like slope-intercept form, y equals mx plus b, except b is 0. So here, in that case, the k would be the slope, wouldn't it, or the rate of change. But anyway, direct variation, if x increases, y increases. If x decreases, y decreases. Okay? All right, let's take a look at a problem out of the book to do with that. And this says, free fall. An object in free fall, so it's just being dropped, travels a distance s that varies directly to the square of the time t. So s is distance and t is time. All right. An object in free fall travels a distance s that varies directly to the square of the time. Now, notice nothing was mentioned about k. Quite often, k isn't even mentioned, but you have to include it in your formula and you have to figure it out to be able to go on and answer for the questions in the problem. All right. So it's no longer y equals kx, it's s equals k t squared. It's still that same form, but we've changed our variables to fit the specific situation. All right, now it says, if an object falls 1,024 feet in 8 seconds, so I'm going to put 1,024 in for s and 8 in for t. Don't forget t is squared. So now I've got 1,024 equals what? 8 squared is 64, so 64 times k. What would I do now to solve for k?
Divide by 64.
Correct. And let's see, 1,024 divided by 64 is 16. Okay, so now I know k is 16. So that goes back into my original equation or formula. So now I've got my general formula for this problem. Okay, so I knew it was direct variation. They gave me some information that I used to determine what k is. I put that number in for k. Now I'm ready to answer the follow-up question, which is this. How far will it fall in 10 seconds? So the unknown distance would be 16 times 10 squared, which is 16 times 100, which is 1,600, and that is feet. So how far would it fall in 8 seconds? 1,600 feet. Any questions about that?
No, I don't have any.
So there's an example. Okay, great, yeah. So there's an example of direct variation. All right, next we're going to look at inverse variation. General form, y equals k divided by x. During this situation that we're in here, do either of you still go, are you like coffee drinkers where you go to a coffee place and get a latte every day or something like that? Do either of you do that?
Not every day, but I do.
Okay, so how often a week do you, typically in a typical week, how often do you go and get a coffee or a latte?
Probably like once
Just once a week?
or twice.
Okay, let's
Maybe
go.
like every other week.
Wow, okay, let's go with Daniela, and she said twice. So 2 times. What do you pay for it?
Like $5.
Okay, so you go twice a week and it's $5 each time, okay? Now, what if the price went up to $6? Would you still go twice a week, do you think?
Probably not.
Would you go once? Maybe?
Yeah.
Okay, so one time if it's $6. If it was $7, would you still go once?
Yeah.
Okay, how about 8?
Probably not.
Okay, so 0 times. All right, let's go the other way. What if it was $4? Would you still just go 2 times, or might you go more often?
I'd go more often.
How often do you think for $4?
Probably 3 times.
3 times? Okay. How about if it was $3? Would you go more than 3 times?
Yeah, I'd go 4 times.
Okay. What if it was free? Would you walk around with like 2 coffee cups in one of those helmets with a straw coming down to your mouth, or maybe just an intravenous needle just go straight into the vein for caffeine kind of thing?
Yeah.
All right, so let's look at what's happening here. As the price goes up, the amount you're willing to purchase goes down. As the price goes down, the amount you're willing to purchase goes up. So instead of direct variation where they both go up together or both go down together, you've got this inverse situation. Price goes up, amount you buy goes down. Price goes down, the amount you're willing to buy goes up. Does that make sense?
Yes.
So that's what this is, inverse variation. Again, K, the variation constant, is there. Let's take a look at an example of that. Okay. This problem is about organ pipes, you know, a pipe organ kind of thing, okay? And you've got all these different size pipes, and the bigger the pipe, the lower the frequency, those really low notes where the whole building shakes kind of thing. All right, it says the frequency of variation, excuse me, the frequency of vibration, I can't read very well this morning apparently, the frequency of vibration of air in an organ pipe is inversely, or is it varies inversely to the length of the pipe. All right, so I'm going to let F equal the frequency of vibration, and L is going to be the length of the pipe. Okay? It says the frequency of vibration of air in an organ pipe varies inversely to the length of the pipe. So I get F equals K over L. So instead of Y equals K over X, I'm using F for frequency of vibration and L for the length of the pipe to fit the scenario. All right? Any questions? It says if a pipe 2 feet long vibrates 256 times. Now, given that information, we can determine what K is. What would we have to do to get K by itself?
Multiply by 2.
Multiply both sides by 2. On the right side, the 2's cross out. On the left side, we get 512. So K is 512. So now our formula becomes that. So just like in the last example, we determine K, we put that into the formula. Now we've got our general formula for this problem. Follow-up question. How many times per second will a 6-foot pipe vibrate? So how many times will a 6-foot pipe vibrate? So 512 divided by 6, and we get 85.3 repeating, which is 85 1/3 times. Okay. You all right with that?
Yeah.
Yeah.
All right, and now for our third kind of variation, which is called joint variation. General formula, Y equals K let's see, they use X and Z. Are either of you married?
No.
No.
No. Okay. Well, do you know what a joint checking account is?
Yeah.
Okay, what's a joint checking account?
That's where the money's like the account shared by both partners.
Right, right. Okay. So yeah, which is what I was getting at. You know, which wasn't trying to get real personal. Are you married? But so a joint checking account or a joint savings account, there's more than one person connected with that account. So joint variation, we have more than one variable connected with this equation on the right side. Okay. And now we're going to look at an example, and this says oil storage. The number of gallons of oil that can be stored in a cylindrical tank varies jointly as the height of the tank and the square of the radius of its base. All right, let me draw a picture to represent this tank. And you can see why I don't teach art. Let's see, we're told it's 20 feet high and its diameter, let's see here, is 15 feet. So anyway, it's 20 feet high, diameter is 15 feet, okay? It says the number of gallons of oil. So we're gonna let, let's see, we're gonna let G equal gallons of oil that can be stored in a cylindrical tank varies jointly as the height of the tank. We're going to use H for height. And the square of the radius of its base, R, is going to be the radius of the base of base. Okay. So G stands for gallons of oil. H stands for the height. So this is H right here. And the radius, R, stands for the radius of the base. Is the 15 feet, is that the radius?
No.
What would the radius be?
7.5.
Right, half of that. Okay, so back here, let's see, a number of gallons that can be stored. So G equals K times, let's see, very strong is the height. So H and the square of the radius. So KHR squared, that's our formula. All right. Now, it says the constant of proportionality, which is the variation constant, is 23.5. Oh, so in this problem, they're giving us K. Find the number of gallons that can be stored in the cylindrical tank. So the unknown is G. They gave us K. Do we know what H is?
20.
And what was R?
7.5.
7.5.
All right, 7.5 or 7.5. And don't forget, R is squared. So let's see what I get when I multiply that all together. 23.5 times 20 times 7.5 squared. And I'm getting 26,437.5 gallons. So this tank will hold 26,437.5 gallons of oil. And that's an example of joint variation. You all right with that?
Yeah.
Yeah.
Okay. Let's see. I want to do some formulas versus writing versus formula. For instance, let's say that the directions say A varies directly as the square of P. If we wrote that out in symbols, A varies directly as the square of P. Notice again, I put K in there even though it wasn't mentioned. All right. How about this one? T varies directly as S. Z varies inversely as the cube of T. All right. How about this one? D varies jointly as R and T. So you've got direct variation, inverse variation, and joint variation. Now, how about this one? This says P varies directly as the square of A and inversely as the cube of J. So what's going on there? We've got a mixed combo, so to speak. We've got, what is it, direct variation and inverse variation in the same formula. So that can happen. All right. Let's go the other way. Let's say we've got this situation. A equals KR cubed. How would you put that in words? You'd say A varies directly as the cube of R. Let's see this one. P equals Km over N. You would say P varies directly as M and inversely as N. So again, you can have sort of a combination of two. Now, you could have direct variation mixed with inverse variation or joint variation mixed with inverse variation, but you wouldn't have direct variation mixed with joint variation because it would still just look like joint variation. You understand what I'm saying? Direct and joint. Okay. So that putting those two together, it would just still look like it was joint variation. All right. That's all I've got for you today. So I'm going to stop the recording.